Hey, welcome to one of my coding sessions of the language we're creating, Bangalang, the low-level explicit compiled procedural language that can run on the CPU and GPU. I don't know if I should do that spiel every time, it's getting a bit, I don't know, doesn't sound interesting anymore if I do it all the time. Anyway, we're working through our bugs, issues / issues list. I'm thinking that once this list is done, which includes check all to-dos, which is kind of another hidden list within the code. I think, you know what, I'm going to move all this to here. Yeah, so what we have is nice to have features. And dev tools is actually above because I think they're more important, especially LSP. LSP, let's put LSP at the top. That's what I'm most looking forward to, actually. So, what are we going to tackle in here? This is the one that came to mind. Enforce return in all code paths for procs with return types. Yeah, we want to make sure we return something if it's needed. I think that's important. So here my idea is that we will keep track of whether we've seen a return or not. If we get to the end of the procedure and we have not seen a return, and that needs to be a return for all code paths. If we have not seen a return for all code paths, then we put an error and say you need to do a return. We can also do something about, like, if you do a return early and then there's code afterwards and it's not reachable. That could be nice. So how do we do that? Well, I guess the first thing I said was that we'll add something in here that says like found return, and that'll be our bool. So in our context, we know if we've found a return, and of course in the return, this is something I didn't fix up before. There used to be a special case where if you did a return at the module level, then the return was a U8, because that's what exit codes are in my language. But you can't do that anymore. You can't do a return from the module level because I made it so that everything needs to be a declaration at that level. So we can cut that out, and then we have something a bit simpler. This is to do with type checking the expression of the return. So I think we can just at the end maybe say found return equals true. Or even at the start, maybe it's the first thing. We've found a return. Obviously, we're type checking one. Okay, and now this idea of all code paths. So I think if and switch are the only places where code paths diverge. I mean, the only other the only other flow control, I guess would be the term that we have, is the for loop. But that just loops, I think it's like, so I don't think it's really a special case. I am in the context going to say, when we end an anonymous scope, then we pass the found return back up. So if we have nested scopes, so for a for loop, if a for loop has a scope, right, which is the body of the for loop, and that's an anonymous scope, and if there was a return that happens in there, then when we leave, we want to say, hey, there was a return. Returned in there. We want to propagate that back up. But ifs and switches are the most interesting because there's like the if scope. This here I think is the else if scope, and this is the else scope. So to say that there was a return from all code paths, all of these need to have found a return. And we need to say that there definitely was an else. Because if it was just if, else if, then it might not have entered any of the branches. So saying that there was a return from all those branches doesn't mean that we're guaranteed to return, because we might not go into any of them. So if we say like found all returns, oops, and then after the scope we can sort of say we're going to look at the context found return, because it would have got set while we're in here. So if that got set, then do we say found all returns? Actually, maybe we'll say if, we'll start with true. We'll say it's true. And if it's true, then we'll set it to this. So when we go into the scope, well, this is always going to be true in this case. Then we will update it to be the result of this. So it could stay true if there was a return in here, or it could become false. And then let's reset this to false. So when we go into the next scope, we can see again. And then so the reason I structured it like that is because now I can just repeat this down here. So if found all returns, which means that this one returns true. So far we've found all returns, great. That means we set it to whatever was in here. So if we didn't find a return in there, now found all returns is false. But if we did, then it remains true. And the same in here. So now we know if we found all returns, and maybe I can say found else, and we can say found else is true. And then at the bottom, we can say found return equals, we found all the returns and we found an else. Yeah, so everything returned, all the branches had a return, and there was an else included in that. So the else did return and was there. I think that says that we returned from all code paths. And if there's nested ifs, that should work pretty seamlessly, right? That should still work. So that's keeping track of it. Then the idea was that when we get to the end of a procedure, so I guess procedure has some checks in it. So this is to do with this is the operator on the right-hand side, checking the allocator, checking the body of the procedure. This is checking the operator. I feel like that feels better here, to do the operator before we do the right-hand side. Just feels like the natural flow, left to right. Okay, so then after this, we say if we needed to have a return, so if there was a return type, so this is the procedure type, so that's the parameters is the first child, and the return type is the second child. So if there is a second child, that means there was a return type. And if the context did not find a return, then that means we needed a return, but we didn't get one. We'll make that just node. Let's say procedure what did I call it in here? Did I call it left-hand side node, I guess? So that should be the name of the procedure. Procedure does not return value. We'll say must return a value. There we go. Procedure must return a value. I mean, we could specify the type, but I don't think that's important. If they try to return the wrong type, then they will get that kind of error. Procedure must return a value. Okay. And we'll get to switch soon. But let's test that first. If I go into the playground, and I make a new procedure, we'll just call it test. And we'll need to call it. So we made an empty procedure called test. That should be fine. Test has already been declared. Oh yeah, I declared test down here. Okay. What about bloop? I don't think I've used bloop yet. There we go, that's fine. So if we try to return a U8, but we don't return anything, procedure bloop must return a value. Very good. So if I say return 42, it's happy. If I say if true, it doesn't look at the condition. It's not that intelligent. So like this could technically at compile time we could see that this is always returning, but I'm not going to bother with that. So it says we must return a value because there was a return in here, but it was not for all paths. If we go else to return 43, then it should be happy. Yeah, now it's happy. If I say else if true, yeah, it's not happy. So it needs to have the else to be happy. Okay, I'm pretty happy with that. I think that's good. Okay, so now let's try the switch. I guess it'll be very similar. This one is kind of just like looping through all of the possibilities, all of the cases, I should say, in the switch. So if we can probably just repeat this pattern. Switch. So after we type check the scope, we do the same thing. So we need to have this found all returns. Like so. And switches have a default case, which is kind of like the else in if, you know, it's the catch-all. So for all, for us to know that all branches return, there needs to be a default case that also returns. So just like we had in the if, we had found else. Let's say found default. So we're checking here that it's not the default. Maybe I'll switch that and then we can go like this and say found default equals true. So then we can have something very similar down here, where we say found return means that we found all the returns and we found a default. Okay, so if we go back here, we change this to a switch. So bloopy is 42. So if we switch bloopy, I need to try and remember the syntax now. Is it case 42? I must, hopefully I've got a test for a switch. No. I can't remember the syntax for switches. Do we have any switches in Bangalang code? No. Okay, let's go to the switch parsing to remind ourselves. So it needs the switch keyword. Okay, great. And then an expression, then an opening curly bracket, then a case node. Well, it's not a closing curly bracket. It could be the keyword default. Otherwise, it's a right-hand side expression followed by a colon. So I didn't think we used the keyword case because I would have made it nice and colorful. So I guess it's just this. So is that valid? Type I64 and U8 are not compatible. So I should make bloopy a U8 if I'm going to return it. Okay, procedure bloop must return a value, which makes sense because 42, we don't have a default. So if default also returns bloopy, then it's happy. Okay. I think that's about right, yeah? So I guess that we should do, if we did a test here, if this was just like an empty scope, yeah, must return a value. So it needs to return from all of them. Yeah, I'm pretty sure that code's right. You know, it's not so complicated. So now we've made sure that we've enforced return. The other side, which is not in my to-dos, but we'll do it anyway, because we're feeling generous, is that we want to make sure that we don't have statements after a return, because that's pointless. I think I'm just going to make it an error. We could potentially change it to a warning later. But I think warnings are a bit more complicated. Just because I actually want to get into, there's another part here related to returns, remove the default return when not needed. And I think this will be easier if we just throw an error in this case. So I think it'll be type checking of statements again. So we have these checks, and now I think, so before we type check a statement, I want to say, if we found a return, like if we found a return and we're about to type check a statement, that means, because found return means that before this point, all code paths have returned. Which means that this statement is redundant, or it can't be reached. So let's say statement cannot be reached. Yeah, I think that's about it. So everything should be fine. Yeah, because we don't have a return. But if I do like return bloopy up here, we don't have bloopy yet. If I do return bloopy here, then on line 9 we should see, yeah, line 9 statement cannot be reached. So we have that error because we could never get here. Cool. So let's just return 42 and run that. And now I just want to have a look at I want to get down into the nitty gritty of the assembly. So we go symbol, playground assembly, and we search for bloop. Oops. Find bloop. So this is the bloop procedure. And see we have 2 returns. Here we're setting the return value and then we're returning, and then we have this default return, which is pointless. What are the other cases? Like if we didn't have a return value and we did return, and we have a look in here. See, it's just 2 returns. So let's see if we can remove that redundant return. So this is the one that feels most redundant, I think. We've done this, there's no point in this. Maybe I will also, because I feel like an important part of this is the allocations. So maybe we'll bring back bloopy and return bloopy. Because when you return, you need to deallocate. Yeah, see, this looks quite a lot more complicated now. Why is it copying like this? Huh. That seems strange. It's a stack variable, but this is like a memory copy. I don't know why it's doing that. That seems quite pointless. Or maybe it's because the place we're copying to is considered memory. I don't know. Anyway, we won't worry about that right now. The point here is that we have like this deallocate return, and that's quite redundant. So I think this is in the procedure, was the generation of the procedure actually. x86 procedure. We don't go into generation much these days. But yeah, this is at the end. So we generate the body. This statement is the body of the procedure. It should be a scope. And then at the end, we add this default return. This deallocation, do we ever... The thing is that when we go into here, because we know this is a scope, it didn't used to be the case, but now it is. See, it does its own deallocation, deallocates everything that was in the scope. So is this needed? Maybe it's for deallocation of the parameters? But we don't have any allocations in here. So I don't think so. Oh, well, we saw in the assembly that it does exactly the same deallocation. So I guess in the case where we don't have a return value, if we go back here and take off the return value, what does that look like? Okay, again, it's like pretty pointless. So yeah, what I'm thinking is this ever needed? I don't think it is. We're going to get some crazy errors if we find out that it was needed, which makes me think we'll just leave it. Let's just leave it, just in case. But we only need to do this so the thing is, now that we have required a return statement when there's a return type, because this is not valid. Oh, did I? Okay, I should finish what I was doing here. Let's just say if true for now. Yeah, because that's valid, or no, it's invalid. We would only ever get to here for a procedure with a return value, we would have already returned, guaranteed. So this will only happen when there's not a return value. So if length of this, the first child was param type, second child is return type. So if there's no return type, then we do this. So if I return bloopy, and we find the procedure, so we still have the deallocation. I guess the deallocation was actually happening in this as part of the stack. So this deallocation in the procedure was really doing nothing. It was really doing nothing. Okay, let's leave it anyway, because I'm more scared of what will happen if we remove it than what will happen if we keep it. At least we got rid of the return. I guess that's something. So that's when we have a return value. And I guess the thing is that if we don't have a return value, it would only duplicate if we have return like this. That's the only way it would duplicate. If we have this return at the end, which is redundant, it's pointless, then we would end up with two return statements here. If we put it anywhere else, we'll get statement cannot be reached. And if we say if true do return, then it's legit that we need to have, like this, say it's if false. If false do return, so it's never going to return there. It's always going to use the default return. So here, see, we have like this is the if, and we're going to return if we go into the if, and here's our default return. So I think that's pretty good. I think we've gotten rid of the return for basically all cases. The only case where it would still exist is if we do this, which is kind of stupid anyway. So I feel like I'm not going to bother optimizing that, because just don't do that. That's pointless. And it's not so much of a code optimization. Well, I guess it could affect, the instruction cache, the I cache, because you're putting pointless instructions in the assembly. But I digress. I think what I was trying to say is I think this is enough for now. We do have this no, that deallocate is also needed. Yeah, I think this is good enough. So I'm going to take this off, remove default return when not needed. Oh, that was that. Now, there was some other things, because we're only halfway through. There were some other things I was thinking about tackling. Directives as nodes. I've rethought this. Or no, actually, do I want to make it a node? I need to think about it in the context of alignment for other allocators. In which case we need to store, like at the moment, the alignment is align 4. So we needed it for this because this needs to be aligned for Linux to work properly. I can't remember exactly what it is that needs to be aligned, but it's something in here. I should probably also allow, the alignment of members, but I don't think I do that, and it's okay. I think it might be is it the mutex or the semaphore? Something like that. Something needs to be aligned. Anyway, I wanted to change it to align equals 4 and allow like 1, 8, 16, 32, and 64 as different alignments. Which makes this a little more complex. But I do want to change, I don't want it to be called a directive, I want it to be called a modifier, because that's basically always what it does. It modifies whatever it's applied to. So let's go into type, no, it's AST types. Let's close a bunch of these. Well, hopefully that should work. To do as node, question mark? Yes, node please. And let's call it a modifier. So I guess we probably want to have, I was going to say that we want to have I guess technically it's like an assignment. I don't want to get too crazy here with like everything as an assignment. Like it should just be very restrictive, basically identifier, and optionally it can have equals integer. That's it. That's enough for now. So in terms of nodes, we can have an identifier and it might have a child, which is an integer literal. I think that's plenty for now. So I guess this gets a bit more complex. Modifier is not nil. Then we want the modifier dot value and has a dot after. Maybe we'll put like an equals. So we'll just keep things simple. Always have an equals, and if the modifier has children, then we'll add the child value as well. So we'll add the children 0 dot value. So that should be the number. Geez, that's long-winded and ugly. What else we got in this file? This looks like the same thing, basically, with the space separator. Here we used a dot separator. So let's go up, put this here with a space. All right. Now we want to know whether it was hash private, so I guess the modifier could be nil. Do we want like a... I think we'll make a utility. Oh, it's the same file. You have all these is, so maybe we'll say like has modifier. And that should return a bool. So first we'll say if modifier is not nil, and node modifier equals, so we need to pass in a value to compare it to, equals that, return true. Then the next thing is we want to check the data type. The modifier of the data type, if there is a data type. I'm thinking about having a null coalesce, like, I don't know if that's what this is called, but this kind of thing, which is in like TypeScript and I think like C# or these kind of languages. Instead of having like, make sure this is not null, make sure this is not null, just have a question mark. So if the data type's not null, this is $value, and the data type modifier is not null, and the data type modifier value is the modifier, then return true, otherwise return false. Now an extra added thing here is maybe in some cases we don't want to check the data type. So like, where were we checking just before? Here. In this case, we're checking if something is private. So the data type, so this could be the declaration of a value, which could be private, and so okay, we want to not return it. But if it has a data type, which is for whatever reason marked private, that should not prevent the value that is of that data type from being seen, right? Is that right? I hope so. So when I do has modifier, like this, something doesn't look right here. I feel like it should be, because we are in AST, so we don't need it. That's why it looked weird. So I'm going to put false as a third parameter. So it's like check data type, and we'll call that true by default. So if check data type and in the case here, we're not going to check the data type. Okay. Now we go up here. So this is changing the name. What the hell is this? It looks like I pasted directive into value by accident. So it should be like that. And that should be nil and dot value. Like so. Cool. That's taking care of that file. I don't think this file is needed anymore. So if we're danger untyped, yeah, so I think this is good here. We would want to check both the node and its data type for danger untyped. I think this approach is also good because I think currently I try to like copy, I think I copy the modifier from the data type to the identifier or something, but I can just avoid that whole thing just by checking both places. Okay, so now we're saying the type node danger unbound. I feel like it doesn't have to be just the type node. It could be the looks like it's not saved anywhere. Could be just the child node, because then it'll also check the data type, right? So we child node and we go ast dot has modifier. Oh, this is not equals. Need to be careful that I don't screw these up. That was not equals. And the util file, where did we do it? Here. Yeah, this is looking for where we do have private. Yeah, okay. All right, moving right along. This is our alignment stuff. This is what we're working on right now. Well, I guess we're doing two things at a time. We're making it a node. We're making these nodes, and we're also doing this, making our alignment better. So here we have this alignment for. So I guess it's sbprintf line %s. Maybe we also need to do get modifier. Yeah, maybe instead of has modifier, we do get modifier, and we can compare it to nil. To return node.modifier, node.data type modifier, and nil. So if we return nil, that's the same as having returned false before. What's wrong with this? Oh, it's because we have node here. What's more descriptive? I would like to say identifier, but we might pass a. Let's just say identifier. It's fine. Because we could pass a data type in potentially. That's why like identifier doesn't sound quite right, but it's fine. Okay. So that should break a couple of things. Yeah, it has modifier. So if get modifier is not nil, so there is a private modifier. If get is not nil. Did I get that other one right? If it's not nil, so there is a modifier. Here we're saying that there is a danger type. Yeah, so that one's not nil. Confusing myself. Okay. Here we're going to say get modifier equals nil. So if it's not boundless, then we do bounds checking. That makes sense. That seems happy. Okay, so this is why I wanted to do it. So we do get modifier. See here, we're looking on the node and the type node. That's what get modifier does anyway now. So I'll call that alignment is the align modifier. So we need to update parsing. We need to update parsing for this. And I guess the grammar technically we should update as well. So if alignment does not equal nil, then alignment.children. I guess we also want to say, and because they could put alignment without equals something. So just to cover that, we'll say and alignment dot children. There is a child, and the value of that child should be a number. And it should be 4, 8, 16, 32. So I guess, do we need to validate that, I guess, somewhere, that those are the values? And maybe if we find, so maybe if we find a line, we need to validate that there is a second part and that it does satisfy one of those numbers. So then when we get to generation, really, it should already be handled. So it should just be a case of this. We need to make sure we add those checks. Here we're going to say modifier is make node with the type identifier and value danger untyped. I feel like I'm getting a bit too comfortable with really long lines. Maybe I should prevent that a bit. So the modifier is that. Danger untyped identifier node. Here I want to do like has modifier on the node, which will then also handle the type node where it does not have this. So that's equals null. Get modifier. Yeah, that's fine. I thought we would have another one here. Same thing. Cool. Still need to keep in back of my mind that we need to have checks for alignment. We need to validate. This is where I was talking about before we do this copying business. So we try to get the directive from where we can, and then after we do type check primary, we override the data type one. I'm pretty sure we can just cut all this out and actually just do this and actually just do this. Yeah, that's much simpler. Very nice. Okay. Here we want to add a directive or a modifier. So make node, which is an identifier with a value of SOA, like so. Here we are checking for the presence of SOA, currently just on the data type. Can we put SOA on a value? We don't really do any validation of modifiers. We should generally restrict where modifiers can appear, I guess. At the moment, if you put a modifier somewhere where it doesn't do anything, then it's just ignored. I think it would be better if you got an error though, so that you know that you're doing something pointless, something that's not supported. Yes, I was just trying to think, should we use get modifier here? Or should we just look on the data type? We could have a data type that's a struct, and then the value is an SOA of that. Yeah, okay. So let's say node SOA is not null. So it has an SOA modifier. So we should change this token type to be modifier. And I guess this needs to be make node now. And what is it? Value equals modifier. There we go. So we're applying the modifier to this newly created node. This is where we're saying so this modifier is a token type. Yeah, which is, which is like a special kind of identifier. There's no node type of modifier. It's just an identifier. But I just realized if we come across a modifier, the extra thing that we have in parsing now, or is there somewhere else in parsing where they can show up? Because now we can say if tokens.peak token in the stream has a type of equals. If we find an equals token after, then we consume the equals token I don't think we have integer, I think we have number. And we also consume a number token. So maybe we need to actually say modifier as an identifier node. Modifier.modifier. No, modifier.value is this value. So we just assign modifier now. And if we find equals, then we consume equals. We say append to modifier.children. Don't need semicolons in this language. A new node, which is an integer literal. Isn't that a node type? Null, number literal, where the value is this value. I think we can do some of these guys to make it a bit more readable. So we get the value from that token. So I think we'll do a similar method up here. Okay. So we get a modifier node, we optionally add a child to it, which is a number literal. Okay. So hopefully that's the only place in parsing where that happens. Otherwise, I guess we can just extract it. So this is where we create the modifier token. No, this is another place that it happens. We have a directive. Okay. So let's have, in parsing, let's have a new file, modifier. And it'll be parse modifier. Haven't made a parsing function in forever. I think it was primary we did it before, right? So basically it needs to do this. Yeah. And parsing functions, I guess, have this kind of signature. I think we can just put the body in first. Then we'll steal this signature. We don't need the primary type. I guess we need AST. I guess we don't need source. Return modifier true. Okay. I think that's it. So we've created a parse modifier. So in here, we can just say that this is the result of parse modifier. We pass in the stream. I think that's it. Yeah. And then we pass the primary and then we apply the modifier. So this here, was it left-hand side expression? Where was it? A left-hand side declaration. So in here, we're trying to do this. So I guess if we find a modifier, then the modifier becomes the result of this. So it should be a pointer to a node now. Then we do our normal identifier stuff, and then we assign the modifier. Yeah, I think that takes care of that. Okay, so this is copying the modifier over. I think we can just, and I've got it to do here. I'm not sure if this is even necessary, but we'll just leave it as is for now. Okay, we have a crash. So we're checking the data type, the identifier modifier is that. Identifier is U8. Does not have a data type. I think it should be this. Yeah. Yeah, that last one is right. Yeah. Got that a bit wrong. Okay. That seems to have run. Let's do a couple of tests. So at the moment we've already got the static stuff, right? I mean, does the OpenGL work? That's where we actually use it. Oh, expression syntax error. Interesting. So OpenGL NASM 863. Whoops. 863 is It's because I put this hash align equals 4. Maybe instead of the equals, I'll put a dollar sign because dollar signs seem to be okay. So that was in, I think it's called type var name. Here we go. Yeah, so I put this equals in, so let's put the dollar sign instead. Okay, it's happy. And if we look at here, we should see, yeah, align 4. So this is the thing that needed to be aligned, so it has the align 4 still, so that's good. And we should be able to, just as an extra quick little test, if I put align 8, it should still work because it's 8 is a multiple of 4. And we should see align 8. Okay. Go back to 4. So that's all working, which is great. I think one last thing I wanted to do is just the validation. So whenever you find an align modifier, where are we? Here's my tea. We need to make sure that it has a value, has a number literal, and that number literal needs to be one of 1, 4, 8, 16, 32. So to find out where they can appear, we can go back to our parsing and we can see it was left-hand side declaration. I mean, the grammar also says it, right? Which says directive still, so I'll change that to modifier. So primaries can have them and left-hand side declaration. Yeah. And I mean, a left-hand side declaration kind of, because it doesn't, well, it has a type primary, which can start with a modifier. But this is after the colon. So this is really limited. Okay. All right, sure. So there's the 2 places that they can show up. So if I go into type checking left-hand side expression, we don't specifically have a declaration part. So if this node, we're checking the data type, allocator modifier. So we're checking the data type here. We probably check we do check the allocator. We want to check the modifier. I think that's also just for declarations. So that would also be like here. And is this where we would see an align? I mean, mostly it's on the data type, which would be the type primary. If we saw an align here, I believe it would get ignored. Although, no, it could be the variable, because the way we do, if we go back to generation, the way we do it was in primary, wasn't it? Wasn't it? Oh, this is type checking. No, it's not. Oh no, it's in program because it's static stuff. So yeah, we do has modifier on the left-hand side node. So it could be here. Okay. So let's do this type check modifier thing. And when we are in a primary, because a primary, oh, not in generation though. Go to a primary. Yeah, if we come across a modifier, we can do it in here. this is parsing. I was thinking, like, am I sure that I didn't think that there would be, I don't think we explicitly do anything with a modifier in here. So I think we'd probably do it like up here somewhere. Is it specifically before an identifier? Modifier. It could be a modifier of. Interesting. I think it needs to be specifically on an identifier. And an identifier that's not a member also. Well, we're talking about a primary, it would only be a right-hand side primary. A left-hand side primary wouldn't make sense for, right? If we go back to the grammar, closed it again. Left-hand side primary doesn't have the ability to do it. So it just wouldn't appear. That's okay. So on the right-hand side or in a type, it could happen. Okay, so anytime that it can happen, we'll just check it. We'll just put it here. I think that's fine. So let's make a new file. Modifier.odin. Oops, I put an extra I in there. Let's just copy some existing file so we get the correct signature. So yeah, that looks about right. Let's keep some code in here that has an error because we want to throw errors. Okay, so I think we can say if well, I guess here we should say, and also here we should say if node.modifier is not nil, then type check that modifier. That feels better. So the thing with this node is a modifier. So if the value does not equal a line, there's nothing to check. At the moment, we're only checking a line. We can do better checking later, because at the moment you could put any modifier and it would just, if it's not something valid in a certain place, then it'll get ignored. You could do, you could do hash this and it wouldn't throw an error. So if it isn't a line, then we say if it has no children, which is to say that it has no value assigned to it. Let's say the align, let's say hash align, the align modifier must have a value. And then if slice dot contains the value of the first child, if the slice does not contain that. Oh, the alignment. I guess, no, we do have slice, we don't need strings. seems like we have some sort of dodgy, maybe it's because we need to do it this side, I forget that. Okay, so it needs to be one of 1, 4, 8, 16, 32, 64. Like so. And if it's not, then we say the align modifier must have one of the following values. So I guess we could say, like, we could put that error for both of them. And if we take this slice and we put it up here, align values. I prefer this syntax personally. Then we can say, put the align values in there, the align values here, and a %s. Okay. Because I'm a stickler for like the way I structure these messages, there are some, yeah, it's required to be one of. Is required to be one of. There we go. So that should do that. I'm just realizing now, actually, what's wrong with this? Parameter node. Oh, because I need to pass in the context. And here. But one extra thing we need to check. There was something else I was thinking I need to check, and like we can't do it from in here right now. Oh yeah, so the original message here that I used was align for stack vars, and then in brackets and other allocators. So actually, the stack is the one place where we can't use it. Well, we could, but it's more difficult and I can't be bothered right now, so I'm not going to support it. The other allocators, the custom allocators that we have right now, support it like out of the box. I did some investigation. It turns out that mmap that we use for allocating heap memory actually allocates a page aligned memory address, which means that it could be super efficient if you do lots of little allocations, because each time it's essentially allocating a whole page, which is like 4,000 bytes or something. So yeah, that could be really bad. But the side effect is that the memory you get back from it is always aligned to 64 bytes. And it turns out that for OpenGL allocations, it's also, it's not quite as big. It's at least 64 byte aligned. So they implicitly support them. There's nothing we need to actually do. So we need to just need to make sure that if it's stack allocated, that we don't do align. So I guess that only makes sense on the left-hand side expression. So here we're checking specifically the modifier for the value, not for the type. And now we need to say, like, if we're using the stack allocator, we're using the stack allocator, which we also need to make sure that it's not a member. Yeah, so if the allocator is, no, so we convert it to the proper one in here, don't we? Yeah, here we go. So if the allocator equals the built-in stack allocator, and the allocator is the built-in stack allocator, and we have the modifier if get modifier align, alignment. So if alignment is not null and we're using the stack modifier, the stack allocator, it's not allowed. It won't work. Cannot apply a stack allocator to or maybe it's just like cannot align a stack allocator. That's fine. That's good enough. Okay. Let's run this. We're happy. Pretty keen to get this this sorted. So like everything's working. I'm just going to do a health check. Module level statement must be a declaration. Oh, we didn't fix that up. That was something from the last session. Because none of these tests have a main procedure. They're all just top level statements. So, and I did have an idea of how to fix it, so we should be able to fix it pretty quickly. If we just need to wrap them, we just need to wrap the code of each test in a main procedure. So main proc equals %s, no, %s. And we use the main code. Scope must begin with, why is it doing that? Format.println, we'll print the main code, because maybe this is not printing up properly. Ooh. Sometimes the brace, that's right. I think we have to escape the braces like this. var 0 has not been declared. So that seems to have fixed that problem. Cannot use compound literal for type. Okay, this is a bit of an aside. Before we get too deep into this, we will fix this. But the last thing I wanted to test, we need to test our validation, right, that we just put in. So if I go back to the playground, we'll cut out this stuff. Don't need that anymore. But this is a stack variable, so if I go hash align equals 4, oh, that's doing it. That's doing a health check. Cannot align a stack allocator. That actually doesn't sound very good. Stack allocated value. Yeah, let's say that. That's a bit better. And what if I do like 6? I think that gets caught first. Cannot align a stack allocated value. I thought that should get... import here. Shouldn't it? Shouldn't we go into here? Huh, we don't go into there. But I thought this is the left-hand side node. I thought this should get the modifier. Oh no, it's on the type. It's on the type. So maybe that does get type checked later. I mean, the data type gets type checked here. So does it doesn't go into there? It does. It's a subscript. Yeah, subscript of byte, right? Yeah, U8 is byte. Okay. We step in. Wait a minute. We step in. Hash align. Oh, it should be hash align. Lucky we do this testing. So now, yeah, the value of the align modifier is required to be 1 of, but we don't get the correct position information, and that's because the parsing, we didn't add it. So when we parse the modifier, we also need to do the source position. So token.value, token.source position. Let's do the same for this one as well. So the same modifier token and unknown value token. At this point, I don't care that much. Value token. So now if we run it, we should get, yeah, we get a nice position message. Should be 1 of these. Okay. So I'm happy with the alignment code now. We can cut this out. So let's go back to this health check business. This is the last thing that I want to try and resolve, because we're nearly getting an hour and a half. We were just under an hour, and I was like, oh, let's just do one more thing. Cannot use compound literal for type. Already got a breakpoint here. Where are we? Where are we? Node source position is main anonymous proc in line 4. Main anonymous proc. Ah, that means we're in the anonymous proc. Yeah, the anonymous proc test, line 4. Well, I think maybe this is line 4. So we're here, and for some reason it thinks we're talking about a compound literal. Why would we get into there? Right-hand side expression, We're type checking the right hand side of an assignment. So it's a scope, and it should be treated as such. Oh, it says not procedure definition. But this is a procedure definition. It's an anonymous procedure definition. That's the point. So this condition, I think, is wrong. If it's a static procedure, if it's not an identifier, so it is an identifier, say it's an identifier and the data type's not nil, the type of the data type is procedure type. So none of those should go to false. If it's a member and something, is it a member? For it to be a member, it would need to have children, which it does not. But it does not have a code or a null allocator. Okay. It does not have one of those kinds of allocators. So that will return false. So it's not that. It's not a static procedure, so it has a procedure type. We already checked that it does. It has a right-hand side. Yes, it does have a right-hand side. If we look at the test, so this is the right-hand side of the assignment. And the right-hand side type is a scope. Shouldn't that be true? All those things? Wait a minute. Can we just have a look at the history? I think I messed this up. Yeah, you see that? Must have done some copy pasting. That's what it was. Let's try that again. I'm surprised that nothing else broke because of that. Okay, now it's thinking for a while longer. Let's see where we get to. Beautiful. Okay, now just before we finish up, we'll just confirm that these other two programs run properly, and they do. Awesome. We got a few things done there. We made sure we enforced return types. Oh, and this directives as nodes. We can cut that out. We improved our alignment code. And we removed default returns when not needed. Oh, that was just a bit of a rearrangement. Wicked. So we took 4 off this list. I mean, we were there for an hour and a half, but 4 off the list is pretty good by me. Okay, enough for today. Thanks for stopping by. Have a good one. Ciao for now.